Good day, everyone. I am Justin David D. Palma from grade 11 STEM 2. So I'm here to have a video tutorial about pre-calculus. And my chosen topic is identity and conditional equations. So first, before we proceed, let us define what is identity and conditional equation.
So when we say identity, it is an equation that is true for all values of variable in the domain of the equation. So the domain of an expression or equation is the set of all real values of variable for which every term of the expression or equation is defined in the set of all real numbers, such as this example. So we have the example of identity equation. So the given that we had is cosine squared x minus sine squared x over sine x plus cosine x is equal to cosine x minus sine x. So when we recall from the sine and cosine functions, they have their domains in the set of all real numbers that will satisfy the given equation or the given expression that we had. So as we simplify the equation, rather the expression on the left side, which is the cosine squared x minus sine squared x over sine x plus cosine x, to be equal to the expression on the right side of our example, which is the cosine x minus sine x. So first that we do is we use a squared minus b squared equals a minus b times a plus b to factor the expression. So we have cosine x minus sine x times cosine x plus sine x over sine x plus cosine x. So after that, we reduce the fraction with sine x plus cosine x. So we canceled out this part. So we canceled this. So the next is the simplified identity of an equation. So which is state that it's equal to the left of the expression on the right. When we say conditional equation, it is an equation which it must be false, at least all elements, so from its domain. If the conditional equation is false for every value in its domain, then the equation has no solution. So conditional equation is also called contradiction. So I have example there, so watch out for it.
The example equation that we had is x squared plus 49 is equal to x plus 7 squared. So by inspection, the left side of the equation is not algebraically equal to the right side. However, there are values of the variable that will make this equation true. But some values will not satisfy this equation. We can say that the given equation is true on the condition that x is equal to 0.
A trigonometric identity is an equation involving trigonometric ratio of an angle where the equation holds true for a defined range of values of it.
In trigonometric identities, we have three. We have y is equal to sine theta, x is equal to cosine theta, y over x is equal to tan theta. The identities that we had is cosecant theta is equal to 1 over sine theta, or sine theta is equal to 1 over cosine theta. We have also secant theta is equal to 1 over cosine theta. Cosine theta is equal to 1 over secant theta, or cotangent theta is equal to 1 over tangent theta, or tangent theta is equal to 1 over cotangent theta. Tangent theta is equal to sine theta over cosine theta, and cotangent theta is equal to cosine theta over sine theta. Sine squared theta plus cosine squared theta is equal to 1. Tangent squared theta is equal to secant squared theta minus 1. Cotangent squared theta is equal to cosecant squared theta.
So for you to truly understand and to enlighten your mind, I have the numbers of examples of trigonometric expressions. So the first example that I had is this example. So we have cosine x plus sine x tangent x. So the first step that we need to use or that I use is the quotient identity for tangent. So this tangent turn this. So the tangent is equal to sine x over cosine x. So the second step that I use is I write all the numerators above the common denominator. So we have cosine x plus sine squared x over cosine x. It transforms into cosine x squared plus sine x squared over cosine x. So after that, another identities I use. I use the reciprocal identities and simplify the expression. So I use reciprocal identities in cosine x squared plus sine x squared, which is it's turned into 1. So cosine x squared plus sine x squared over cosine x. So the fourth step that I use is I apply and use the reciprocal identities of secant and transform the expression. So I use the reciprocal identities of secant and transform the expression, which is it turned to 1. So this is the fourth step. So the answer or the simplified trigonometric expression is secant x. So this is the example number 1. So more example, more the happier or the more learning that we learn. So this is the example number 2, or I have the another trigonometric expression that we need to simplify. So the trigonometric expression that we had is cotangent squared theta over 1 minus sine squared theta. So the first step that I use or that I apply is I use the quotient identity, which is I use quotient identity and cotangent squared theta. So cotangent theta is equal to cosine theta over sine theta to transform the equation. So it transform na po. So we have cosine theta over sine theta squared over 1 minus sine theta squared. So the second step that I use is I use the reciprocal identity to simplify the expression 1 minus sine theta squared. So this is the transform expression. So we have cosine theta over sine theta squared over cosine theta squared. So that. So the third thing or the third identity, or rather, I use the properties of exponents. So this part. So we have cosine theta squared over sine theta squared over cosine theta squared. So we simplify the equation that turns here. So it's also a simplified expression in this. So the fifth step that I use is I use the reciprocal identity of cosecant. So in this part, I use the reciprocal identity of 8 cosecant. So it turns to 1. So we have cosine theta squared, sine theta squared over cosine theta squared. So use the reciprocal identity of cosecant. We have 1 over sine cos theta squared. So this is the simplified trigonometric expression. Next in the line is another trigonometric expression. So we need also to simplify this trigonometric expression. So we have the example number 3, tangent squared x times 1 plus cotangent squared x is equal to secant 2x. Secant squared x rather. So the first thing that I do is I use the Pythagorean identity in this. So it transforms to this expression that we had. So tangent squared x cos secant squared x. So the second thing that I use is I use the quotient identity for tangent. So I use quotient identity for this. So tangent squared, this tangent is equal to sine x over cosine x times another identity I use is, and that is reciprocal identity for cosecant. So this. So we have this expression na. So we have sine x over cosine x times 1 over sine x squared. So the third or the fourth that we need to do is reduce the expression with sine x. So we need to cancel out. So this cancel this. So after I cancel that, So we have now the expression 1 over cosine x squared. So in this expression, in this part, so I use the reciprocal identity for secant. So when I use reciprocal identity for secant, I got the simplified trigonometric expression, which is secant x squared, which is equal also to the right side of our example expression. So we had it's so it equal to the expression example natin. So, that's all for the example number 3. Sad na nasa last example na tayo, which is the example number 4, another trigonometric expression. So, we have the example cotangent x plus tangent x sine x. So, in this equation, the first thing that we need to use is the reciprocal identity. We need to use the reciprocal identity of tangent. So, it's sine x over cosine x. So, we have the equation cosine x plus sine x over cosine x sine x. So, the second step that we need to do is we need to have the common denominator, write all the common denominator. So we have the expression cosine 2x plus cosine squared x plus sine squared x over cosine x. That's not t, it's cosine x. So after that, the thing that we need to do is use the Pythagorean identity. So we use Pythagorean identity here. So Pythagorean identity. So we come up with another expression. We have cosine squared x plus sine squared x over cosine x. So this next step is I use reciprocal identity for secant. So here, this. So after that, we come up with the simplified trigonometric expression, which is secant theta.